You're all set.
Let's get going. So thank you, Stephen. Thank you all for being here today. I'm Al Martinez. I'm an associate professor in the Department of History at the University of Texas here at Austin. I work on history of science, mainly history of physics, some history of math, but especially Einstein and relativity. Too ambitious is myths about Einstein, relativity, and religion. I'll have very few about the last one. But let's get started. This is, as we know, we have this impression of this world-famous professor circularly groping towards unity. Here he is, a cosmoclast Einstein. Matter is speed and flame. Said anything of that sort. That's what it says there. Of course, you see him in stamps, whatever country you like, if you're a collector. There, in his tongue, it's Einstein. There's another one in there. There he is again, and Rwanda, multiple places, Portugal, Congo. I hope some of us in this room will make it to be in a stamp in the Republic of the Congo someday. So, this larger-than-life character, almost a an old Hebrew Bible prophet. If we talk about Einstein this way, merely 60 or 70 years after his death, how will people talk about him 2,000 years? Let's see if this will click. Genius problem. So in relation to the genius problem, #1 New York Times bestseller, my first myth that I want to suggest, I can't possibly prove this, I don't want to be more ambitious than I should, that Einstein was a genius. What does this actually do? What does this actually do for us to create this category, this otherworldly genie, or this person who was maybe touched by God or had special powers, a different brain, whatever. We envision him as somehow different from the rest of us. The more I've studied Einstein, the more understandable he becomes, not just as an individual, but as a phenomenon. Essentially, something happens to this guy, history takes him and does a number of things with him, and he resists. He doesn't want those things to happen. Sometimes he plays to the cameras, but for the most part, he's very uncomfortable with it. And all I can do to kind of convey what I mean here is, maybe I'll give you a quotation by Einstein, but I'll give you one brief example of what I'm getting at when I say this. It's been called by a sociologist the Matthew effect. Essentially, when you are famous, you are going to get more fame. So, for unto him who hath, more shall be given, and from unto him who hath not, more shall be taken away. So people are giving Einstein all kinds of credit. Well, he did some interesting work on Brownian motion. It helped to give us a sense that these invisible particles actually exist, called atoms. So then the cartoon becomes Einstein proved the existence of atoms. That's the cartoon. Einstein discovered or convincingly proved. People didn't quite believe this until Einstein does the Brownian motion. People had been talking about publishing, writing equations about atoms for decades. And yet, nowadays, many people are comfortable lumping that credit onto Einstein, something he never gave to himself. This is the way he describes it. In 1919, he suddenly becomes world famous when his predictions for the deviation of starlight observed from Brazil and the coast of Africa confirm that starlight does deviate according to Einstein's laws of general relativity, his theory of gravity. They follow more closely than another theory he had proposed, and which was known as the Newtonian theory. Suddenly he's world famous, everybody wants to talk to him. Newspapers are heralding this as a book for 12 wise men. They say people can't understand him. They treat him as some sort of a superhuman. And he writes to, he says to a Dutch newspaper in 1921, he says, "It strikes me as unfair and even in bad taste, to select a few individuals for boundless admiration, attributing superhuman powers of mind and character to them. This has been my fate, and the contrast between the popular assessment of my powers and achievements and the reality is simply grotesque. Normal historian or writer or biographer of Einstein reads this and say, oh, what a modest guy. He's just being modest. I think he's saying the truth. I think this guy is really trying to defend himself from this, what sociologist Robert K. Merton called the Matthew effect, which is start lumping credit onto people that is partly credit of others, and you know, the world just doesn't want to hear it. We can talk about that one, but let's move on. This is the contrast that I want to give you. You saw the images as we know him, and now here are actual photographs from the time shortly before he does the work on theory of relativity, the photon theory of light and Brownian motion. This is when their second child is born, Einstein and his wife. You can see that these are relatively modest and unassuming, homely pictures. This is his reality, his existence. He's just another guy. This is the real Einstein, not from the cover of Time magazine and colorful murals. This is the real guy. That's where he lived. I took these photos. I mean, the decorations are recent, but that's the apartment where he and his wife are living by 1905. And there you can look out the window, and by 1905 he publishes this in this journal, publishes this article on the electrodynamics of moving bodies. And interestingly, this becomes later known as the theory of special relativity, for which part of his fame depends. And yet, you know, there is no big reaction among physicists about this. It takes, you know, for years he continues his job outside of a university. So here he is in 1905 when he writes that work. His child, his son Hans Albert, is about a year old when this photograph gets taken. My argument that he is a regular guy hinges on the following biographical information. Gets a bachelor's in science in teaching, so essentially a teaching certificate for teaching physics and math. That's all he has. Lowest passing grade in his section when he's graduating. He wants to become assistant to a professor. He fails. They don't want him. His family business collapses in Italy. He lives in poverty for a while. Gets his girlfriend pregnant. They have a daughter out of wedlock. He never visits her, never visits his daughter. Somehow she disappears from the historical records. He has the makings of a deadbeat dad early on. He becomes exempt from Swiss military service because he has a sweaty, flat feet and varicose veins. He self-teaches himself Maxwell's theory of electricity and magnetism, which means that he is an amateur. He says that he applied for jobs with a bunch of professors at many places and that he was rejected by every job in physics in Europe. He submits a PhD dissertation in 1902. It is apparently rejected, so he withdraws it. He fails to become a high school teacher, which is what he is qualified to do. He becomes a tutor in physics and mathematics. He's not particularly good at that. And then he, thanks to a friend, he accepts the lowest rank job in the Swiss patent office, something that he is not trained for. And on his spare time works on physics as an amateur. He calls himself a heretic, what physicists would nowadays describe as a crank or a crackpot. So he's a government bureaucrat in a cheap suit, as he describes himself, a federal ink shitter. So the interesting thing is, how is it that this guy, this regular guy, you know, like many of us, becomes this successful physicist? At one point, I think in an interview, he says, if you look at my childhood, you would see that I'm not a genius. But somehow he becomes extremely successful. And of course, when he tries to represent himself, people just don't believe him. And they would rather believe, following the traditional canons of admiring saints and religious hero, that he is some sort of an otherworldly genius. Myth number 2, about the physics. This was discussed many years ago by a historian at Harvard University, Gerald Holton. A famous experiment performed by an American physicist, Albert Abraham Michelson. known as the Michelson-Morley experiment. What the Michelson-Morley experiment tries to do is it tries to detect the motion of the Earth through the ether. So if the Earth is really moving through this invisible stuff called ether, and light consists of waves in the ether, we should be able to detect the motion of the Earth by just doing an experiment in this room. Without looking at the stars, we could do an experiment in this room that tells us planet Earth is moving that way. We should be able to do it. When they try to do it, it doesn't quite work. So it turns out that because Einstein's key equations for the special theory of relativity of 1905, when he's just a government bureaucrat, living with his wife and his second child, his key equations can be obtained very quickly if you analyze the Michelson-Morley experiment. Then naturally what people did, rather than do the historical research to find out this cute neglected thing known as the truth, is they said, aha, these are kind of the equations of the Michelson-Morley experiment. Einstein gets this from the Michelson-Morley experiment. Physics comes from experiments. This experiment led to Einstein's relativity. It becomes an important myth in physics education. Even to this day, it's still around. Here's the experiment. Essentially, we're going to shoot light through this half-silvered mirror. You know, when you're watching TV or CSI or some show, they're interrogating the suspects and they're behind the so-called one-way mirror. Of course, one-way mirrors don't exist. What really exists is a half-silvered mirror, meaning that it's got a reflective substance to about half of the degree that a normal mirror has. That means some light will hit it and bounce off. Some other light will hit it and go through. Well, the light that goes through hits that mirror and bounces back. The light that bounces hits this mirror and bounces back. And then what we're going to do is we're going to observe, in this case there's the telescope, we're going to, or the viewing lens, we're going to observe the two beams of light coming back together. And we're going to be able to compare whether or not they have changed. The reason they should change is because if you notice the distance from the source to this mirror, the mirror is moving away, so it should travel an extra distance to get to the mirror, and then a shorter distance to get to this mirror and bounce back to the viewing point. So you got to analyze that longer plus shorter, and then compare it to that diagonal plus this diagonal. Intuitively, they should be the same, but if you actually do it mathematically, you see that it should take light a little bit longer to do this round trip instead of that one. They do the experiment, they expect a certain shifting of the fringes that they should expect, Abraham and Morley. They don't detect it, so it seems to confirm the one result that Galileo and Copernicus most wanted to deny, which is the Earth is not moving. Physicists, of course, were unready and unwilling, as I am, to say the Earth is not moving. So instead of thinking the Earth is not moving, they then had to explain this experiment. How can it be that even though the Earth really is moving, we cannot detect its motion? So they've got to do some interesting things. And this diagram just shows you the reality. The paths are too short if we only do it once. So here what we actually do is we bounce the light beams a bunch of time in the opposite direction, so then we can compare the total travel time. There's a photograph of the device. It is, all that it does is it measures, once you shoot light in this direction, you shoot light in that direction, the two beams come back. All you see are just some fringes, so you don't know anything. All you know is you see some fringes. But maybe it takes longer for light to go that way than this one. Maybe. If it does, then we can take the entire device and rotate it, which is why it's on a round platform floating on a pool of mercury. We can take the entire device and rotate it, and if it does take a different amount of time for light to travel in one direction as opposed to the other, then those two times should shift as we rotate this thing. So here's the device, and of course when they rotated it, they didn't detect enough of a fringe shift to conclude that the planet is moving. There's just a diagram of the same thing. So the interesting thing became that even though the school textbooks told us this interesting story about how the Michelson-Morley experiment led to Einstein's special relativity, when people actually asked him, because that's an interesting, cute thing that you can do as someone who's interested in the truth, you can actually do some research, historical research, and try to find out if something that just sounds right is actually true. They asked him, how did this influence? Did you read it? Did you know about it? You know, I don't remember. Yes, I did. No, it didn't influence me much. I knew about it, but it didn't capture my attention. So he says a series of hesitant statements that made historians conclude, rightly so, that even though he was dimly aware that this was one kind of experiment that had been done, it did not lead him to the special theory of relativity. Instead, there were other experiments. And again, since what I'm interested in is the evidence, then the interesting thing is, what did he actually say that affected him? If you take a telescope and you want to see a star, it turns out that throughout the year, you have to tilt the telescope slightly in the direction of planet Earth's motion to actually see that star in focus. You have to actually, if the planet is moving in that direction, we've got to tilt the telescope slightly in that direction. Otherwise, we're not going to see the starlight in focus. So Einstein realizes, as well as other people, that if this telescope is full of water, which is an interesting, why would you fill the telescope with water? Well, you want to fill the telescope with water because if you do fill it up with water, then you can do something that we wish we could do, which is change one of these variables. If it's true that the reason we have to tilt the telescope is because the Earth is moving, if that is true, you were ready to accept it, I'm ready to accept it, but physics has, you know, there should be some sort of confirmation to our ideas. If it's true, then we should be able to test it. For example, let's change the speed of the planet. We change the speed of the planet, then we're going to see if we have to change the tilt of the telescope. Sorry, can't do that. But what you can do is you can change the speed of the light. How the hell can we change the speed of light? You put some water in here. You put some water in here, it will slow down the light. So then you're going to, you should be able to detect some sort of a different effect. Namely, a different tilt for the telescope. Turns out you don't have to tilt the telescope any differently. So Einstein sees this as a puzzle. And he likewise sees as a puzzle, interestingly, another experiment about moving water. The telescope was on, water was in the telescope is moving, so it's moving water. Likewise here, there's moving water. There are two tubes in this arrow. Water is coming in, and it flows around that tube, and it goes in this direction, and then it goes out there. So we've got water flowing in one direction through two tubes. And now what Armand Hippolyte Fizeau by 1850 proposes is he proposes we can measure how the motion of light affects water. Does it affect water? How does it affect it? He says, okay, let's fill up these tubes with water, let's shoot light through these tubes, and then let's move the water. If we can move the water, then we're going to see if maybe the light somehow affects, if the water somehow affects the light. So again, what's going to happen is there's a source of light here. Light is going to come towards this lens. It's going to bounce against that fully silver mirror, and then it's going to go through. Some of the light is going to go essentially in one direction. Some of the light is going to go in the direction of the moving water, and some of the light is going to go in the opposite direction. So if the water is moving in that direction, some light is also moving in that direction. For example, the light can be going this way and then that way, just as the water is moving, or the light can also go in the other direction. You bring the two beams of light together, and again, what you see is just some fringes of light, some interference. Light beams interfere with light beams, and you see some fringes. What does that mean? Nothing. But if you change the speed of the water, you should be able to see a change in the fringes. They do that experiment. He does that experiment long before Einstein, and they detect the lines do shift. They shift as if the moving water is somehow slightly dragging the light. Somehow the moving water is affecting the speed of light. So you've got an experiment, the aberration experiment of starlight, that seems to show one result. Essentially, the experiment doesn't clearly show whether light is being dragged or not, and then you've got here an experiment in which the light seems to be dragged. For Einstein, these experiments are very puzzling, and they are instances of what leads him to analyze the relative motion between moving bodies and light. The moving body is the water, the experiment is, and then we're seeing how light changes relative to this moving reference frame. So what's interesting is that Einstein talks about this as a crucial experiment. Again and again, when Einstein is doing presentations about special relativity, he talks about these experiments. But the interesting thing historically is how instead of focusing on what he's actually saying, when the guy's trying to explain to you what he's done, it's the same thing as with the story that Einstein's just a genius. We don't want to hear what he said. We don't want to hear what he said. It just comes from Michelson-Morley experiment. That's what it is. By 1903, he's discussing philosophy and some physics with a couple of buddies, mathematics PhD student and another philosophy student, Moritz Solovin, Romanian. And in those discussions, they discussed the writings of David Hume, Scottish philosopher, 18th century, treatise of human nature. And what's interesting about this is when Einstein does recollections, he's trying to explain to people how he came up with the theory of relativity. Actually, he gives credit to his reading of Hume. He writes, for example, to the philosopher Morris Schlick in 1915, "Your exposition is also quite right. Positivism suggested relativity theory." Again, notice how totally contrary that is to what we want to think. We want to think now, well, positivism is just nonsense. It's just, in universities, positivism is a bad word. He's literally telling this guy, positivism suggested relativity theory without requiring it. Also, you have correctly seen that this line of thought was of great influence on my efforts, and indeed, Ernst Mach, and still much more David Hume, whose treatise on understanding, he kind of garbles the title. I know there's two versions, but apparently he read the one on human nature. I studied with eagerness and admiration shortly before finding relativity theory. And then he says, very possibly I would not have come to the solution without those philosophical studies. Steve?
Can you give a little capsule of positivism for those of us that are not in philosophy? I'm sorry,
So essentially, the problem is that this word has a long history from a course on positive philosophy of the 1830s by Auguste Comte to what it became in the early 1900s, a movement called logical positivism. But essentially, one of the distinctive aspects of positivism was the idea that metaphysics and any statements that cannot be converted into operations have no meaning. So it was an attempt to get rid of certain classes of metaphysical or abstract statements from philosophy and to give this optimistic, scientific take on physics. So, but the interesting thing that I'm highlighting is David Hume, is this idea that here's a guy who is telling you that something that was deeply influential to him is David Hume. Try to find this in a physics textbook. You're not going to find it. What you're going to find is the Michelson-Morley experiment, and they're going to tightly connect it. Even if they don't say Einstein was inspired to this, instead, that's how they're going to tie. So again, there's a beautiful lesson there in the difference between what we imagine with, oh, Einstein's just a genius physicist who through experiments has led to the theory of relativity, to the reality, which is he's a regular guy like you or I, who, having been neglected and rejected by the system, still perseveres and using philosophy thoughtfully is able to analyze all the experiments into questioning the notion of time that physicists take for granted, and for them is a non-legitimate problem of physics. And he says this, for example, also in a letter to his good friend Michele Besso, who says, wasn't it your reading of Ernst Mach, who I suggested that led you to relativity? And Einstein says, yeah, I read that, but I can't see any influence. It was more my readings of David Hume with Solovin and Habish. And then I have this here. This is a popular version of his theory of relativity he publishes in 1917. This one is relatively recent. The one about Michelson experiment has been around for decades. This one has only been around for maybe 30 years now. So this one is growing. It's never going to go away. So don't think that it's going to be dismissed or these things have a dynamic, and you have to understand the power of myth to understand why these things work. Einstein's first wife secretly co-authored his theory of relativity. Here you have him. He does look kind of evil in this picture, crowding in on her. And there she is as an incoming student in the physics and mathematics section that Einstein was also entering into the same year. She's about 4 years older than him, and she's from Serbia. She's bright, and the question is, did she somehow contribute to relativity? Here she is with some friends. This one liked Einstein, this one hated him. And here's how the story got started. By the 1980s, historians of physics finally got their hands on a set of letters that they knew probably existed in the hands of the family of Einstein's first male son. And there in one of those letters in 1901, in Einstein's handwriting, he actually tells his then-time girlfriend, not yet his wife, how proud I will be when we both together have brought our work on the relative motion victoriously to its end. That's it. The uncritical reading of text would lead us to think that's it. There. She co-authored it. She's working with him on it, and he's sharing this with her. That letter led to a number of questions. You know, to what extent did she contribute to his early work in physics? After all, even though she didn't graduate from her bachelor's in science in physics and mathematics, she did study the same things he did, and soon enough they were living together by January 1903. So here it is in a PBS show of 2003. There she is beautifully working on experimental physics, and there she is working by candlelight while Einstein smokes, as I've said, his crack pipe and puts his feet on her face. So you see this beautiful, compelling documentary. It gives you the impression that this stuff really happened, that somehow he did steal credit from her. And thus when they released it, this is how the accompanying website originally looked like. It said, for example, why was she erased from Einstein's life story? But that's the interesting thing. The question itself is false. She wasn't erased. He even talks about it in one of his short talks about her in one of her short autobiographies, and she was also talked about by biographers. What significance does she have? Autobiographies never mention his first wife. Totally false. The world only learned of her existence through the first release of Einstein's private letters. Absolute nonsense, complete fiction. Anyone who knew about Einstein knew that he had two wives and that she was the first one. So it's interesting how in one paragraph alone they can pack so many fictional claims in a way that just will make it sound as though they're talking about the truth. Did Mileva Maric collaborate with Einstein? You decide.
So this wasn't on Fox.
No. So you take the online poll, and I write about before you're about to vote, then that before you actually vote, you just read this page, now they want you to vote, you click on the thing, they want you to vote, and how could one human being alone, a regular guy, do everything? He must have had secret help. So the secret help is that if the original papers are found, a Soviet physicist now dead claims that he personally saw the original manuscripts. He said, boy, that's really explosive. Actually saw that. And the Mileva's name appeared as co-author. Now you decide. And you vote yes or no. And you know, a year later, 75% of people who responded to this agree, yes, she is his secret co-worker, and thus history is decided by a matter of democracy. The problem, of course, is that democracy is not always the best way to go. So here you have some of the claims. A Serbian biographer of Mileva Maric, she says that this article by the Russian guy pointed out the 1905 papers were originally signed with her name. Another guy writing to Physics Today said that the Russian guy says their author was Einstein Maric. Stated that Michio Kaku in a very well-selling book, she says that the Russian physicist said that he saw these manuscripts and that the one describing special relativity were signed Einstein Maric. The interesting thing is that this is an actual book, Meetings with Physicists. And if you have some curiosity about reality, rather than agreeing to whatever we read, we should check whether that book actually says this. You open that book, it says no such thing. It just doesn't say it. So the claim was also aired in the TV show. So the interesting thing is, where are they getting the story from? What they're doing is this. This is my translation. This is what Abraham Yoffe, a well-respected physicist, actually wrote. It's just an obituary. Einstein dies, 1955. A lot of people write obituaries about Einstein. This is the one he wrote. He says in 1905, Annals of Physics, there appeared 3 articles beginning 3 most important relevant directions in physics of the 20th century: Brownian motion, photon theory of light, and theory of relativity. Their author, unknown until that time, a bureaucrat at the patent office in Bern, Einstein Maric. Maric, the last name of his wife, which by Swiss custom is added to the last name of the husband. That's all he says. This is it. Every one of those claims, adding details such as he personally saw the manuscripts, complete fiction. He didn't see the manuscript. There's no evidence he saw them. He said he saw them. Her name was on them. All of that just grows out of misquoting this one passage in which, in this translation, I haven't transposed any terms, and which he clearly means a male employee of the patent office is the author of this, and it was indeed a Swiss custom at the time. Some people did call themselves by this alliance now, this combination. Again, these discussion buddies, they knew Mileva well. They were the 2 witnesses to their wedding. And if you watch television, then the PBS version says that the center guy, the Romanian, he says, Mileva sat in the corner during our meetings, listening attentively. She occasionally joined in. I found her reserved, but intelligent, and clearly more interested in physics than in housework. What's interesting about this, it has the ring of truth. You know it, you feel in the back of your head, you're like, yeah, she was a physics student. You know it's true. Of course she's more interested in, you know, light and matter and electrons and stuff like that than in dirty dishes and diapers. Of course she is. The problem is, this is television. So the historical question is, did Solovin actually say this? This is Dennis Overby, a best-selling book, Einstein and Love, science writer for all kinds of media. Marriage made Mileva a de facto member of the Academy. That is the discussion group. Solovin recalled her sitting quietly in the corner during their meetings at their apartment following the arguments, but rarely contributing. Reserved but intelligent, really more interested in physics than in health. Here it's rarely, there it's occasionally. And they both have it. So the editor, the people who prepared that show have used this. But again, this is totally irrelevant because it's a book from 2000 that was not written by Einstein, Maric, or Solovin. It's just written by a science writer. If you care about facts, then you try to find what Solovin himself wrote. And what he says is the fact that they were married did not change our meetings. Mileva, intelligent and reserved, listened to us attentively, but never intervened in our discussions. Nothing about her interested in physics more than housework. Nothing about her rarely or occasionally chiming in. Nothing. And if you don't want to believe that one, which is what he actually published, you find a letter that he wrote to Einstein's biographer in 1952. A letter in which he's actually defending Mileva Maric because he is her friend. But in passing, he mentioned she never took part in our discussions, but we didn't feel uncomfortable by the fact that she was there. So this still doesn't explain what got the story started. What got the story started is that quotation from 1901 in which Einstein says, undeniably, how happy I am when we both together have brought our work on the relative motion victoriously to its end. There it is, he says it in 1901. The problem with that one, as I've explained in print, is that the problem of relative motion was a well-known, well-recognized problem on which many people were working on by 1900. So our knee-jerk reflex is saying, relative motion, theory of relativity, there it is, she's the coworker. No. The problem of relative motion is what he's trying to solve, for which he proposes the theory of relativity. The problem of relative motion is what Michelson and Morley were working on. It's what Lorentz was working on, Poincaré. Dozens of physicists throughout the world were working on this problem, and Einstein's one of them. What the letter literally shows is that in 1901 he shares that aspiration with her. He wants her to work with her. Maybe she has worked with him. She wants her to work with him. Maybe she has, but we don't know. We don't know what she did. All we know is that after they're married, and after she essentially doesn't finish her bachelor's, doesn't graduate from college with a physics and math degree, the evidence disappears. So the issue is, here's a guy working on this thing that eventually becomes a theory of relativity for 10 years. In that time period, he talks to a number of people. Michio Kaku, Marcel Grossman, Havish Solovin, Mileva Maric, a number of people, and in 1901, he feels that in some sense she either is or should be his collaborator. Fine, so that's what we can say. We say in 1901, Einstein shared this aspiration with Maric. But in order to actually give her credit, we need a little bit more. So then we should listen to her. How about we listen to her? Could she not write? Yes, she does. There's a voluminous correspondence between her and her friend Helen Savic. Here's a letter translated by a Serbian writer, George Kirstic, who met Einstein's son. The translation is from 1991. The letter is right after Einstein has published relativity theory. She says, "My husband spends all of his free time at home, often playing with a little boy." That's good. But I would like to remark, this together with his official job is not the only work he does. He's also writing a great number of scientific papers. So she could say, "My husband and I are eagerly working on important treatises on electricity, magnetism," but she doesn't. In none of these letters does she say that. Instead, she says, "I want to tell you he's also doing this other stuff." Now, the interesting thing, as I said, is this is just a translation. If we go to the original source, which is better translated by Milan Popovic in 2003, what she actually says is, spends his leisure time at home playing with a little boy, but to give him his due, that phrase has been willfully deleted by the Serbian biographer who is quoting that thing. Literally just eliminated this clause. I've seen the letter in the original German. It's written in German. I've translated it myself. This is a very good translation. I must note that the papers he has written are already mounting quite high. Here, in this version, it's the papers he has written. So that's if you want to care about her version of reality, then again, this is what we see. By sometime later, around 1909, she also writes to her friend that she's very proud of her husband and what he has achieved. Nevertheless, as I said, this is never going to go away. That one piece of apparent evidence, we both together have brought our work on the relative motion, that and other things, people will be looking for. So now she's a national hero in Serbia. There's sculptures of her, T-shirts, scholarships, and so it's just a matter of time before some version of that story makes it into our textbooks. And I like Mileva. I want her to be this co-author. Don't think that I don't. I want her to be the co-author. In fact, I'd be happier if she's the co-author and Einstein's just an evil cheat. That would be great. That would be a great story. We would all benefit from it. It would help women's education. It would help get women into physics. So I want it to be true. But I've got to recognize my biases and then at the same time try to distinguish fact from fiction. Here she is in a TV movie, sitting on Einstein on a bench, as she so usually did, while he's trying to get his work done. You read the original paper from 1905. He gives thanks to his friend and colleague Michele Besso for giving him several worthwhile suggestions. So here you have a guy, you might think, well, this guy just doesn't like giving credit to people, especially to his wife, but he's giving credit to this guy, and did so repeatedly. Moving on, Einstein's theory of relativity was inspired by the clock towers of Bern. This one is relatively new. This story, how many of you have actually heard about this? I'm wondering that he's working in the patent office, and there's applications for the synchronization of clocks. After all, Switzerland is the clock-making capital of the world. Hans, one person, you've heard something about this. That's two. So this one is gaining steam as we speak. This is Michio Kaku's account. 100 years after Einstein has done his thing. In 2005, another theoretical physicist, you know him, City University of New York, best-selling author and popularizer of science. You should have him come along and talk to you guys someday. He writes the following, verbatim, this is what he says. Einstein remembered riding in a streetcar in Bern and looking back at the famous clock tower that dominated the city. He then imagined what would happen if his streetcar raced away from that clock tower at the speed of light. He quickly realized that the clock would appear stopped since light could not catch up to the streetcar, but his own clock in the streetcar would beat normally. He had finally tapped into God's thoughts. So there, you know, Einstein lives there. He lives on this street. There's the streetcar, there's the clock tower. The streetcar is coming towards his house. He looks at the clock tower. He thinks, boy, if I'm traveling at the speed of light, suddenly time is going to seem to stop. On the tower, time stopped. My watch continued. Time is relative. Boom. Beautiful idea. Beautiful. So this is a myth-making process by which different ideas, such as, well, there's a clock tower, relativity of time, have been gradually crunched together until this beautiful story comes of complete fiction. Nowhere did Einstein say he remembered riding a car in Bern and looking at the clock tower. Completely invented. Nowhere does he say that he imagined what would happen to the clock tower if his car is racing away at the speed of light, etc. So the interesting thing is how, from different pieces, the story gets made up, and then that becomes sold. And if you like Michio Kaku, and you're like, there it is, that's great, that's how it happened. I want to say, where does that come from? It partly comes from the 1905 paper. He mentions the synchronization of clocks, synchronized clock at B with the clock at A, and then he mentions if we say the train arrives here on hour 7, what we mean is the pointing of this little clock hand to 7 and the arriving of the clock are simultaneous events. So there he's talked about train, he's talked about clocks, doesn't talk about towers, but what the heck. But the interesting thing is how from these seeds, then people are going to say, boy, man, he's talking about clocks. There's a lot of clocks in Switzerland, there's got to be a connection. So there's the patent office. He lives somewhere here to the left, you know, further out of the picture. I've been there, I took that picture. And then there's, this is where I think the main version gets started. In this novel, the interesting thing about novels is they are fiction. In this novel, the author, a science writers also deal with fiction once in a while, he tells us a fictional story about Einstein having conversations with his friend Bessel. We know they talked. What did they talk about? We don't really know. So, well, let's make it up. So not only does he make up the conversation with Bessel, he also makes up how Einstein is haunted by looming clock towers in his dreams. So there, you just make that up, and then people read it, they forget that that's where they read it in a fictional book, and before you know it, it's infected their history. A story in 1905, The Clock Towers of Bern, inspired Einstein to think of the relativity of time, shows up prominently 10 years later in this book by Harvard historian Einstein's Clocks, Poincaré Maps, Peter Galison. What he argues is that Einstein's a privileged position. Essentially, he is he's working at the patent office, and although initially that makes it seem like he's away from physics, actually, he is in a position that he's closely connected to technologies, especially timing technologies. Patent applications make it to the patent office. Therefore, why not assume that some of them make him into Einstein's desk? Not only did some of them maybe make them into his desk, maybe they inspired him. So you see how it's just a process of freely connecting the dots. It's almost like drawing constellations. We said, that's a Big Dipper. This is not, it's not a dipper, it's a bear. Can't you see it's a bear? No, it looks like a dipper to me. Somebody says it's a baseball cap. So this is the dangerous thing that whenever any of us is working on science, we have to, on history, we have to be aware of. You walk around Bern, you will see these interesting prominent clock towers, as you will in many other cities throughout Europe. So then, the author of that book, Harvard historian, shows us how all these public clocks were coordinated, electrically connected. the clocks were a matter of cultural pride, so the patent office is a clearinghouse for timing technologies. Interesting thing is we have not one shred of evidence that Einstein ever analyzed an application for any timing or synchronization device, none. So what they'll want to say, well, you know, this happened, no such evidence. There he is at his work desk posing for a photograph. And this is how it shows up in the book. Time coordination patents are pouring into the office. Sometime in the middle of May 1905, he and his closest friend Michele Kaku cornered the electromagnetism problem. Then Einstein recalled, suddenly I understood where the key to the problem lay. He skipped his greetings to Bessel and said, thank you, I've completely solved the problem. An analysis of the concept of time is my solution. Pointing up at a clock tower in Bern, one of the famous synchronized clocks, and then to a clock tower in Muri, Einstein laid out to his friend the synchronization of clocks. So again, if you want to trust Harvard historians of science, then you shut the book, you say, that was a great story. I've learned so much. I'm so glad these people are out there able to find these precious tidbits for me. If you instead want to be a skeptic, which I encourage you to be, you should try to find out if Einstein actually ever said that, that this happened. And then the same book has a map. It says Michele Kaku recalled. Again, notice the same structure of Michio Kaku. Michio Kaku says Einstein himself remembered riding on that streetcar, where here it's Meso. Besso recalls that when Einstein excitedly told him about time, he pointed to one clock tower in Bern and another one in the town of Muri, which is up there. Since it is the only vantage point from which both might have been visible, Besso and Einstein must have been standing on the hill northeast of downtown Bern. The author knows the problem. The problem is if you go to Bern and walk around, you're going to see what I saw, which is you do not see the two clock towers at the same time. It's impossible. Physically impossible. To solve something that's physically impossible, what do you do? Well, maybe they must have been standing on this hill. It's the only way. So notice again the construction, they must have been standing. What that means is, I don't know where they were standing. So I'm going to deduce that they were standing on this hill northeast of the city. There's a photograph of the hill, I took it. The interesting thing is that hill is not northeast, it is to the south. So, the map is upside down. Here you can actually see it, here's the map in the book. The hill appears here, but the actual hill is down here. So, it's physically impossible for such a conversation to happen because there is no such hill northeast of the city. So, going back, nevertheless, what we see in the same book is when Einstein gestured towards Muri's only clock tower, this is the structure to which he pointed. So there, I mean, you feel when you see this image, boy, I'm seeing the actual image that Einstein pointed to when he's having this conversation. Here it shows up in a book review, New York Times Review. Suddenly, hundreds of thousands of people can read that in May 1905, on a hill from which he and his friend Bessel could see the synchronized clocks of Bern and the one that had not been synchronized at Muri, Einstein realized in a flash that blah, blah, blah. So he's like, boy, I'm learning. I'm really getting somewhere. I didn't even have to buy the book. Where does this come from? Einstein never said anything about standing on any hill with his friend Bessel and pointing to any clock towers. The story comes from an anecdote told by a different co-worker of Einstein in 1955. Einstein's written his paper, he sent it in, he wants to share it with a co-worker who has experience on electricity and magnetism, gives him the paper, and then the co-worker recalls 50 years later when he's 84. To pin back the ideas, Einstein told me, let's suppose one of the clocks is on top of a tower in Bern and the other in a clock tower at Muri. You're like, there it is, he said it. No, he didn't. Because this is not a conversation with Bessel, and it did not happen before his discovery, it happened after. And they're not standing on a hill. And he's just giving a hand-waving explanation. He's saying, let's imagine. He's not actually pointing at anything. This story becomes misrepresented by a biographer in 1974, saying in this translation, he was observed gesticulating to friends and colleagues as he pointed to one of Bern's bell towers, and then to the one at Muri. Michel Besso was the first person to whom he said this to. But again, Besso is long dead, Einstein is long dead. This is just a garbled version of what little evidence we have, which is that Einstein once in his long life, mentioned a clock tower in a hand-waving illustration. So that's where it comes from. And it doesn't mean that I don't want it to be true. Again, I want it to be true. It's the better story. We want this to happen, but if you don't have any evidence, you shouldn't believe it. He recognizes a definite connection. This is a biographer who interviewed Einstein at length. He says, Einstein recognizes a definite connection between the knowledge he acquired in the patent office and the theoretical studies which at the same time emerged as examples of the acuteness of his thinking. And you're like, boom, there it is, he said it. Uh-oh. That's really bad. Yeah, there it is. He said it. Alexander Moskowski said it. He said it. Didn't he? No, he didn't. Where are the clock towers? Where's the theory of relativity? Where's the hill? None of them are there. He works at the patent office for a number of years, publishes scores of papers, and recognizes that some of his creativity is connected to, working at the patent office. It's a good story. But again, it's not the inspirational creative story saying he got it from working there. It doesn't say anything about the special theory of relativity in particular. All right, saying goodbye to the clock towers. Now this one's interesting. This one is about physics itself. I'm sure all or most of you have heard constancy of the speed of light is an experimental fact. You may have heard something along those lines. I'm going to argue this isn't actually true. As authority, since of course you have no need to believe me, I'm in the history department, why should you believe it? I'm going to use Einstein. Einstein doesn't think it's an experimental fact. He thinks that you and physicists who think this is a fact are just wrong. And that's why he calls it a postulate. A postulate is a fundamental assumption, an axiom, something that you assume before you go on to try to derive other conclusions. So how does this story come about? In order to know the speed of light from here to there, you need to know not just when it departed, you need to know when it arrived. Okay, I'm going to shoot my flashlight at noon. Bam, noon, and you turn your flashlight and you... So now how do you know when light got to that door? Or when light got to Dallas or Houston? How do you know? I don't know. I'll ask somebody in Dallas or Houston to tell me when they saw the flash. Okay. Yeah, I saw the flash at a certain time at 12:05. At, suppose that the 05 is a millionth of a second or something. In order for this to work, notice we've used two clocks, one here and one in Dallas. The only way that can possibly work is if these two clocks are synchronized. Because if the clock in Dallas doesn't say the same time as mine at the same time, then you're going to get the wrong travel time. So in order to say anything about the speed of light, we need two clocks. They have to be synchronized. The question is how. So Einstein has to deal with this problem. Well, one possibility is we synchronize them together and we drag one of them over here. If you do that, there's going to be a problem. And the problem is that, that you move this thing. So you've done something to one clock you didn't do to the other, so you may have affected the mechanism of one in a way that you didn't affect the mechanism. Because I'll move it very, very gently. That's what I'll do. I'll move it very, very gently. Yeah, but no matter how you move it, you are moving it. You're changing its temperature, you're imparting vibrations onto it, you're doing all kinds of things to that clock that you're not doing to the other one. Okay, let's connect them with an iron rod, a steel rod, and then we're going to yank it. And this is going to be activated at the same time as this is activated. Maybe they're connected to the rod, and when the rod moves, they'll be yanked. The problem with this one is here you're pushing molecules together, and here you are pulling molecules apart. How do you know that the pushing and the pulling is transmitted in opposite directions at the same time? Einstein doesn't talk about this. Notice I didn't say Einstein gives you this experiment. I'm giving you examples of my own to explain something, which is why Einstein refers to the speed of light as a convention, why he refers to it as a postulate. Okay, let's do this. Same steel beam, we're going to push it dead center by an iron needle. Do it. Do it. Just do this. Just take a pencil at home, lay it down, and press it down the center to see if it's really going to roll evenly on the left side and the right side. You'll find that in every single instance when you do that, it never never goes at the same speed on this side and that side. It always tilts. Always. Do it. I'm serious. I've tried it. So, okay, well, I'm going to put this on some sort of tracks that are going to hold the beam in place, and then I'm going to, even then, you don't know if it's tilting. So in order to know if the beam is tilting, you've got to do this. You've got to check as the beam is going down, whether it passes this clock at the same time as that one. Only if it does, do we then know that the two clocks are, that the beam is going down straight. So in order to get the beam to go straight, to synchronize the clocks, you need synchronized clocks. Okay, well, let's turn on the light at noon. We're going to turn on the light at noon. Light's going to arrive here, and after it arrives here, we're going to set this to start at noon, but we're going to correct for the travel time that it takes light to travel. The problem is you can only do that if you know the speed of light. So if you don't know the speed of light, you can't make any correction for that. So you're, okay, well, let's have a toothed wheel spinning very quickly. We shoot light through here, it bounces off of this mirror, travels 17 miles there and back again, and then it makes it here. And depending on the speed of the toothed wheel, I can make it go so fast that I will literally block the light from making it back. If I block the light from making it back, then I can go, from knowing the speed of this thing, I can derive the speed of light. The problem is when you do that, what you've derived is something called the average round-trip speed of light. Not the velocity from A to B, instead the round-trip speed. So you think this is perverse. Why would light have different speeds going from here to there than from there to here? Why? Why would it have different speeds? The problem is the planet is moving, and the speed of light is independent of the speed of the source. So if the speed of light is independent of the speed of the source, and the mirror is moving away from the light, then it takes longer the light to reach the mirror, and less time for the light to bounce back because the bulb itself is moving towards the light. So this kind of asymmetry leads Einstein to decide, look, I'm just going to decide, he says, this is where it's creepy, he says, out of my own free will, that the speed of light is the same from A to B as from B to A. You're like, what? Free will? What do you mean out of your own free will? You're just making it up? He says it's not an experimental thing, it's not a hypothesis. This is a stipulation which I can make out of my own free will in order to arrive at a definition of simultaneity. So he's just deciding, he decides that if you put a light bulb there and you turn it on, this gets turned on at the same time as that one. It's just decided, irrespective of the fact that the Earth is moving. And you say, fine, I like it. Let's just do that. And some of you say, no, I don't like it. I don't like it. I want to test that it's true. Well, if you want to test whether it's true, you need two synchronized clocks to measure this beam and measure that one. But you can't, because you need to synchronize them with the light bulb, and then you need to check those. You can keep doing this infinitely. So what Einstein realizes as this underpaid, underemployed, amateur/heretic or crank non-physicist sitting at a lowest level patent office, what he realizes is that measurements about speed depend on the synchronization of distant clocks, and the synchronization of clocks depend on measurements about speed. That is, velocity depends on time, and time depends on velocity. This is it's a procedural circle. Other people, such as Poincaré, have pointed this out. Like, fine, I don't care. I don't care. I'm gonna, if lightning hits spot B and it hits spot A and I see them at the same time, I'm going to say they're simultaneous. That's what he wants you to do. He says, if you see them at once, then they are simultaneous. He says that's a definition. In order to give meaning to the word simultaneity, I want you to adopt this way of talking. Stand in the center. If you see both lightning bolts at the same time, they're simultaneous. You're like, that sounds great, I'll do it. If you do it, then you've got the problem that the guy on the train can also do it. And the guy on the train, there's a burn mark here, and there's a burn mark here, so we can tell which person in the many seats is sitting exactly between the two beams of light, between the two flashes. And then we ask him, did they happen at the same time? Because we care about democracy. He says, no. This one happened first. So now I said they happened at the same time. He says they didn't, but they both applied the same definition that Einstein. So here Einstein's deriving the relativity of time from this definition of what it means to have simultaneous events. So if they're simultaneous for this guy, they're not simultaneous for that guy. We say, well, that's obviously because you're moving, you're on the train, you're moving towards this beam of light, you moron. That's what happened. You're moving forward, so you saw the one flash of light first. He says, I wasn't moving, I was sitting down. I was sitting down, and my hot cup of coffee was still as a lake in the morning, and I saw you dashing by, you in the trees. You say, you're a joker. Obviously, I wasn't moving, you are. The train has an engine. You paid for a ticket, I didn't. You're going somewhere. Don't be a jerk. Admit it. You were moving, so your definition is wrong. The guy says, no. You were moving too, because you were on the planet, and the planet is moving. And then you're like, okay, you're right. We're both moving. I'll skip these explanations because I think we're way over time. So let me just move along to the next thing. But the key thing that I was getting at here is the normal idea that we have, which is the speed of light is an experimental fact, is in disagreement with what Einstein portrays himself as doing, which is that in order to get at some sort of a measurement system, he has to somehow break this procedural circularity. And he does it by postulating that the speed of light is constant in all directions and for all inertial reference frames, everywhere and everywhere. And then if you assume that, then you're going to get all kinds of interesting consequences that we know as aspects of relativity. Wrapping up, the one that has to do with this wonderful setting we have here, that Einstein believed in God. This is one of these byproducts of using Macintosh image on a PC. These lines you see, you can't see it on the recording, but they're there. 1929, this church is being constructed, and Einstein has the dubious honor of actually having his likeness carved onto the stone wall of this portico, or this entrance. There should be an arrow here. Somehow it's not showing. There he is. There he is. And then, yeah, there's the arrow. And then there he is. So not only does Einstein get to experience something that not a single person from any church alive at that moment got to experience, which is to have their likeness embedded in this church. He actually gets to see it, and he thinks, again, this is just part of the mass psychosis in which people are grossly overestimating what he has actually achieved. But it lends credence to the kind of stories that we read based on these quotations. Science without religion is lame, religion without science is blind. An interesting thing is that in that quotation, Einstein does not mean by religion what you mean by it. He means something totally different. He says, for example, if you pray, then you're not religious. It's a series of things like that, by which you would have to actually understand what is Einstein's concept of religious to understand that he's not saying at all whatever you think he's actually saying. I want to know how God created this world. I am not interested in this or that. These are just things off of the internet. This is a quotation that apparently he did say. And just looking at that, especially this capitalized his, we come to this warm, fuzzy feeling, and boy, this guy really does believe in God. And then here he is, someone asked him, or a rabbi asked him, do you believe in God? He replies, I believe in Spinoza's God, who reveals himself in the harmony of all that exists, not in a God who concerns himself with humans and our doings. Professor in the history department, Tracy Madison, specializes in Spinoza, and I asked her, Tracy, did Spinoza believe in God? She laughs at me and squints, and she says, of course he didn't. So again, you would have to actually read Spinoza to figure out what actually Einstein is talking about. But it's evasive. They're just asking him, Einstein, do you believe in God? All he's got to do is say yes or no. And you actually read the record, he's notoriously evasive. Why doesn't he just say yes or no? Why doesn't he just say that? So the interesting thing about Einstein, he doesn't believe in the Bible. He doesn't believe in faith. He doesn't believe in the afterlife. If you die, there's nothing going to happen. He doesn't believe in the immortality of the individual. He denies an anthropomorphic God. He says you shouldn't pray to God, and so on and so forth. His parents are entirely religious. He doesn't believe in miracles.
You said his parents were entirely
irreligious Jews.
Okay.
Irreligious Jews. Strangely, they did get someone to teach him the ways of Judaism because he was being sent to a Catholic school, so they wanted him to get both, but they were non-practicing in every way. 2007 biography, #1 bestseller, Einstein, His Life and His Universe by Walter Isaacson. Isaacson argues, Einstein was not an atheist. He believes in an impersonal God. The interesting thing about that is Einstein actually said it. He said, I'm not an atheist. He said there, you want to believe Einstein? There. He said he's not an atheist. He also said that he does not believe in a personal God. So now Isaacson draws the inference. Therefore, he does believe in an impersonal God. And he says, you should take Einstein at his word. When you look back, you say, that's not what actually Einstein said. He just said he doesn't believe in a personal God. What does that mean? If he's not an atheist and he doesn't believe in it, is he maybe agnostic? Max Yammer, in 1999, in a book by Princeton University Press, Einstein Religion, he writes that Einstein was not agnostic. He says that, not agnostic, and the interesting thing is he does not quote Einstein himself saying that he is agnostic. Once, replying to an inquisitive sailor, Einstein denied belief in a father like God, and he wrote instead, I have repeatedly said that in my opinion the idea of a personal God is a childlike one. You may call me an agnostic, but I do not share the crusading spirit of the professional atheist whose fervor is mostly due to a painful act of liberation from the fetters of religious indoctrination received in youth. I prefer the attitude of humility corresponding to the weakness of our intellectual understanding of nature and of our being. In 1950, in a different letter, he explains to someone else, my position concerning God is that of an agnostic, period. I am convinced that a vivid consciousness of the primary importance of moral principles for the betterment and ennoblement of life does not need the idea of a lawgiver, especially a lawgiver who works on the basis of reward and punishment. So the interesting thing is these guys write these books, they say, aha, he does believe in God, yada, 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 you can take all these quotations, but not the ones in which he actually says, look, I'm agnostic. Do agnostics believe in God? No, they don't deny that God necessarily exists, but they don't believe in God. In 2008, Bloomsbury Auctions House in London put up a letter for auction. Einstein wrote in 1954 when he's nearly 75 years old. A letter to philosopher Eric Goodkind. And Einstein writes in that letter, pretty much this, the word God is for me nothing more than the expression of a product of human weaknesses. So this only came to light, public light around 2008. The word God is nothing for me but an expression of human weaknesses, the Bible a collection of honorable but still primitive legends, which are nevertheless pretty childish. No interpretation, no matter how subtle, can change this for me. The translation is skewed. The original one doesn't say anything about childish. What it says is, the word God is for me nothing more than the expression and product of human weaknesses, the Bible a collection of honorable but still primitive legends aplenty. No interpretation, no matter how subtle, can change this for me. Such refined interpretations are naturally highly varied and have almost nothing to do with the original text. For me, the unmodified Jewish religion, like all other religions, is an incarnation of primitive superstitions. And the Jewish people to whom I gladly belong and with whose mindset I have a deep affinity have no different quality for me than other people. As far as my experience goes, they are also no better at anything than other human groups, though at least a lack of power helps prevent them from the worst excesses. And then he says, I can ascertain nothing chosen about them. So on the difference between a typical freethinker, Einstein said that a freethinker is mainly nourished by opposition to naive superstition, whereas his own outlook was motivated by a kind of humility, a consciousness of the insufficiency of the human mind to deeply understand the harmony of the universe. I've talked long enough. Thank you so much. Happy to take it. We went sticking with us. Questions, ideas, anything that I left too blurry? Please.
So when are you writing your book on Einstein?
I published one 488 pages, this thing.
There you go.
And then later I published, this one has 5 chapters on Einstein, and this one focuses on some of these myths businesses. So this was published in 2009, although I've been trying to publish this in 2003, so it was a lot of years, and then this came out in 2011.
Cool.
Yeah.
That last quote that you showed, you said that only came to light in 2008?
Yeah, some letters by famous people end up in the hands of collectors, and so long as the collector holds on to it and just shows it to their friends, many archivists or editors, historians don't know that the letters necessarily exist. So it's when the letter is put up for auction that that it becomes a media sensation. Because for decades, people have been using Einstein as an example. I mean, here's a guy who says, I am a deeply religious man. He says that. It's true. But what he means by religious is not what most of us mean. It's not what the dictionary means. So a religious person is someone who believes in cause and effect. That's what it is for him. If you accept cause and effect, then you're deeply religious. If you pray to God, then it shows a lack of faith, because you think, you have to kind of go against the order of nature to make anomalies happen, and so on and so forth. So, yeah.
Well, I was going to say, I'm slightly dismayed at how quickly, somebody editorialized it to add the childish.
All that happens
laws
is
in that.
lousy translations are very common. So in many Einstein, I mean, maybe a huge percentage of Einstein quotations are just fake. He just didn't say them. But even the quotations in which he says 90% of the crap people attribute to me, I didn't say. Even that one is fake. But the interesting thing is when you do read the letters and the materials in German, you often find deviations in word choice and things that are just not in the originals.
The letters that you mentioned that he, the sailor, I guess, had written him, asked him about it, and Einstein said, I don't believe in this stuff.
Yeah, it's a private document as opposed to a public pronouncement.
And then the guy wrote back to him again and asked him, I would like this to be known, and is it okay if I should let other people see this letter? And Einstein writes back and says, yes, that's fine. And where it was really clear that the reason he didn't call himself an atheist was because, in his view, atheists were kind of, just really vehemently anti-religion, and he just thought it was silly stuff and didn't want to have anything to do with it.
Yeah. If you look at his published writings and his letters, he is more frank and more frank and candid in private than in public. But we also have to recognize Einstein at 75 is not Einstein at 13 or at 17 or at 26. So here's a guy who's changing his beliefs from someone who is profoundly religious when he's something like 10 years old. He's singing songs to God, and he's abstaining from eating pork, and he's annoyed that his parents are irreligious, to someone who becomes, a very radical thinker by the time he's, 13 or 15, and then later just starts using the word God in a casual way, and then seems to, by the 1920s, be something of a pantheist. He talks about being very interested in Spinoza's pantheism, the idea that God is everything around us, that God is present rather than abstract. And then later, when he's, the curmudgeon, the bitter old man, he does swing more strongly to actually saying, look, I'm agnostic. But if you don't find, I haven't found earlier statements, say in the 1930s or 1915, when he just says, I'm agnostic, hey, let's all get together and have the agnostics at lunchtime. That's not there. Yeah.
Well, it probably seems important to realize that there's probably real repercussions for someone coming out and saying that. 1919 in Europe, and him being the center of Jewish circles, holding him up as this amazing man that even wanted to run Israel. When the science movement it's representative for years.
So yeah, I think Einstein is in some sense politically correct. So he is trying to speak in ways that will connect with many people. And that's why when we read Einstein, we feel he's speaking to me. He's one of us. Like if you feel that you're deeply religious and you believe in God, you read some of his passages, you say, there it is. There it is. He believes in what I believe. If you're an atheist, you're like, there it is. He agrees with me. If you're an agnostic, you say, there it is. If you're Jewish, there it is. And that's what's interesting is how by his effort to be a little bit inclusive and expansive in the way he portrays himself, he ends up being very ambiguous. And many people get annoyed by him and denounce him and say, you know, this is atheism, although you disguise it as cosmic pantheist. What you really are is an atheist. The Catholic Church says that about him. So it's interesting that throughout his life, while now it's easy, now he's dead. Now it's easy to just pick and choose whichever quotations we like. While he is alive, he's a very troublesome guy for some people. Because people are, oh, there goes Einstein shooting his big mouth again. You know, making Jews look bad. Anyhow, it's interesting.
Well, doesn't that go against the idea that it was ambiguous?
It is ambiguous in the sense that if you read the stuff, you will see statements that are literally contradictory. It's ambiguous historically in the sense that people try to understand what it's saying, and they have problems. So why is it that you think something goes against the idea that it is ambiguous?
I'm just saying, when he was alive, mentioned it caused, like, the Catholic Church in particular had issues with what, you know, I mean, you know, he had to be, you know, it couldn't have been that ambiguous, I'm just saying, you know, in that respect, right? I mean, he was saying something that affected, you know, someone.
Yeah, the ambiguity is just more manifested in the fact of some people saying, I don't understand this, or this is contradictory to me, or multiple people simultaneously thinking he said different things. But again, by the time someone is writing saying that he's an atheist, disguising atheism as cosmic pantheism, they think it's perfectly clear. I mean, they've gone through it. You come up with an idea of what you mean by religion. You usually mean some things, such as that there is some being, a creator, a lawmaker, that you have free will, that prayer has power, that there are sacred books, that a representative of God has been chosen to communicate some knowledge from God. And when you go down that list, you actually have to write that list articulated, and you're going to find that Einstein doesn't believe in any of those. No free will, no lawmaker, no prayer, no holy book, no. And then when you go, only when you go down that list do you realize just how far down the spectrum of non-belief he actually is. And then rather than jumping and saying I don't believe in any of it, he takes a step back and says, you know, I really don't know. I'm agnostic. The universe is a big, interesting place. I don't know what the truth is. Yeah.
It just reminds me, I think David Hume was kind of pretty similar. Fascinating that he credited Hume's writings with so much stimulation for his own thinkings. He reads, for example, dialogues concerning natural religion.
Yeah.
Hume wrote, and specifically directed his nephew, I believe it was, not to have published until after Hume was dead. The character Philo in there provides the strongest possible argument against the usual argument for the existence of God, argument from design, or logical argument. But even his character at some point, in order to give Hume, even after he's dead, a little bit of cover perhaps with the church, basically says, oh, but everybody knows we have this natural inclination to think we were all created by a superior being or whatever. And so he kind of tries to muddy the water.
Yeah.
It looks like, he was accused of being an atheist by a church back then too. And he also wanted to have some political, or some power, and so on. So that's been going on. Well, certainly was going on back then. I guess it was true for Einstein too.
Yeah. Thank you. What's your name?
Rick.
Please, Clifton first.
You said Einstein's definition of being religious was believing in cause and effect?
Yes,
okay.
A complete faith in cause and effect. And that's part of it. And he says it at some point. He says things to that effect. He says, this is my religion.
I find it humorous. He spent much of his life railing against quantum dynamics because of its seeming lack of cause and effect, which he always attributed his disbelief in quantum mechanics to his insight into the mind of God. which was wrong. But
Yeah, that's a famous issue about whether God plays dice or not. But
Why do you think
I would agree, that's correct.
when at one point Einstein clarifies some statements he makes about God, later saying, you know, what I meant is nature. Nature doesn't work that way. And it's not entirely clear that Einstein is wrong about cause and effect. You know, sometimes, you know, it goes up. I mean, he's still a minority view, but that minority view over the decades sometimes gains popularity, and sometimes, essentially, you've got physicists who rush to abandon causality. They had something such as the decay of a radioactive particle. They say that has no cause. And because they say that sentence, it has no cause, then when Otto Hahn and Fritz Strassmann actually managed to break nuclei at will by just shooting neutrons at them, when they managed to do that, then Heisenberg says, he's just surprised. He says, I'm surprised it didn't occur to me that we might be able to do that. Of course it couldn't. You gave up on causality. It didn't occur to you that this might have a cause. And now we realize, so you can find events in the history of physics where something that was thought to not have a cause later turns out to have a cause, and now they're just standard parts of textbooks. But normally we tend to think about it more in the abstract, like, I don't know, electron biprism.
right, his problem with quantum mechanics was that he felt it wasn't done. It wasn't the last word.
And he's right about that. So he's right about this. Anyway, go ahead. I know you.
David, right.
Yeah.
I have three little questions. One, you said...
Tell me your name.
Jim D.
Am I right that I've seen him before?
He comes to the Friday things sometimes.
Yeah.
Like your
Jim,
Galileo paper.
Yeah.
I had three questions. One, you said that about the age of 10, Einstein was still religious. Does he say anywhere in an autobiography or interviews where and what caused him to drop that religious view to convert away? Second question, has the 2008 letter been published in a collected letters in German and English? And wherever we go, it's not going to be in the Isaacson biography from 07.
You can find it online, the text. It's, for example, meaning that the actual pages have been published, the actual photo scans have been published in German. Some of the images are blurry, so you can very carefully translate it. I've done that. Or you can find transcriptions. Some people have transcribed it pretty well. But regarding the first, it hasn't been published in the collected papers because they go by decades, and they're only somewhere around 1926 or something right now, the start of quantum mechanics. He does say in the autobiography published in 1949 what happened, and he's reading some science books, and he comes to the conclusion that some of the stories in the Bible could not possibly be true. So the physical concepts or claims of, he doesn't say this, but I'm adding some biblical stories, I wouldn't say miraculous stories, seem to him to be impossible. And when he finds that chink in the armor, he says, so he says, I went through a positive orgy of free thinking. Like, you can imagine this guy just thinking, this is all false, this is all a lie. And that happens about 13, when he's, I don't remember these, no, I haven't looked at this lately, but by about the time when he's 13, he's giving this up.
And very quick third question. Do you have a particular biography to recommend, Isaacson or some of the older ones?
I think an interesting one is a biography by a guy called Jürgen Neffe. It's the one I assigned to my students. But they all have problems. They all have... The nice thing about Neffe's biography is he doesn't talk about Einstein in the same walk on water, gift from God, sage divine, otherworldly being that Isaacson does. In the first 7 pages of Isaacson's biography, you're going to see glorious, reverential, holy, halo. It's just a slew of religious labels that he places on Einstein, repeatedly, miraculous, a canonized secular saint. He just goes on and on about it. You're like, any chance you have as a reader at seeing the human being is obscured by that. Neffe knows this is a deadbeat dad who has done horrible things to his sons, and then you're able to see this more understandable human being who is deeply flawed rather than the fairy story that we prefer. You know, the grandfather, the guy that we want to hang out with by the lake. So Jürgen Neffe still suffers of the same disease. We all like Einstein. I like him. But you know, you fall in love with your subject, and then it's hard tell that you're saying what you're doing is the truth. Somebody around here had a comment? But yeah, Neffe, Neffe, a German writer. It's available in English. But it's not a good biography for the science. The science, you gotta go to other books for that stuff.
Well, okay, great.
Thank you so much.
Thanks a lot.
I've got to go pick up a friend who I offered to drive, but I'm gonna try to convince him to go to the Hyde Park Grill.
Yes, the blue chairs get stacked up in about 4 piles over there.